Microphone.
Ah,
Here.
sound.
Oh,
Sound.
sound.
Sound very good.
We begin to record now, yeah?
Yeah, begin. Сильно. В принципе, история. Ну, наглядно, он только ангел, только на схеме смотрел. Наоборот, я ставил, правильно?
I don't know what questions.
I suggest you just to tell us what we need to know.
Okay.
Starting from the very beginning, some theoretical background, and that's it. Anything that can be useful. We have
Okay.
plenty of time because Dorman will come later.
Yeah. And I'm trying to, 'cause I don't have so much information about, let's say, um, what I normally do. I have this diagram from the dilution refrigerator, yeah. Unfortunately, this is a diagram from a wet system, yeah. That means with liquid helium and liquid nitrogen, yeah. In principle, it's not so much difference, apart of one thing only, yeah. The drawing, I don't know, it's really very small. I don't know if it will be not so possible to see, maybe very good,
This
yeah.
one very cool.
Yeah, okay. But anyway, I just put here only to have an idea first what's a dilution refrigerator, because what you have is a dilution refrigerator, yeah. And the difference between wet fridge, as I said, with liquid nitrogen or with liquid helium, for a dry fridge that you don't have any liquid apart of the cold trap. You can say, oh, it's not liquid. Why you have liquid nitrogen there? The nitrogen is for the small cold trap you have. Yeah, you don't need to use any liquid here.
It's
You know,
impossible.
it's awesome. Yeah, that is.
Ну, потом титры сделаю.
Значит,
Then I have this diagram, and you can see here. In principle,
if you stop for a
Yeah.
minute, I just briefly tell. Эта схема для этого заливного криостата, тот криостат сухой. Ну, разница в том, что в одном случае заливается жидкий гель и так далее, а просто газы, компрессоры, то есть вот тоже.
until 4 or 5 years ago, all the systems that we produce was wet. Yeah, you have to first to pre-cool with liquid nitrogen. Yeah, remove the liquid nitrogen, put liquid helium. Yeah,
Complicated.
yeah, because it's the only way to achieve, let's say, 4 Kelvin, because helium is 4.2 Kelvin. You have this base from 4.2 Kelvin, then you begin from 4.2 Kelvin cooling down. Yeah, and you need helium to pre-cool not only the old system, but then to pump, because if you have helium and you pump on the helium, it can go down to, let's say, depend of the pump, but let's say 1.5 Kelvin. Yeah, and that,
Понятно, да, в чем речь? Что сначала прикол идет, заливается сначала азот, потом жидкий гелий, и после этого, значит, с помощью откачки, да, температуру, ну, не с помощью жидкого гелия, а того, что его охлаждается, на полутора Кельвин можно довести от 4.
the advantage now is with this system you don't need liquid helium, because the helium, when you speak now liquid helium, it's all the time helium-4, yeah, because helium-3, you have to imagine helium-3, 1 liter gas costs at 2,000 euros, yeah. If you have 1 liter liquid, 1 liter liquid is 750 liters gas. That means to have 1 liter liquid helium-3, you need 750 multiplied to 2,000. That means you need 150,000 euros to have 1 liter liquid helium-3. Yeah, this will be. But that's why we use helium-4. Yeah, liquid helium-4 is much cheaper, but the helium-4 in the world decrease. It's like gasoline. The price is increasing, and in 50 or 100 years, probably the price will be so high nobody can pay for that. Especially in US and in countries like the countries they don't have recovery systems. Yeah, I tell that because in Germany or in Europe in general, you have these systems, these wet systems with liquid helium, connected to a recovery system. That means you recover all this helium they boil off, and you try to compress again to get the liquid, because it is expensive. It is cheaper. Helium 4 is cheaper than helium 3, but still expensive. Yeah, and then someday, if you just boil everything out, you don't have more helium in the earth, and then you cannot do anything. You have to go to another planet to. But the idea is to save helium, yeah, and that's why we try to invent something that, let's say, you can achieve also millikelvin, but you don't need to use liquid helium, yeah. And in principle, the only problem we could imagine is only to pre-cool the system. If you can have the system at 4 Kelvin, and then you can use our dilution refrigerator to cool down, but you need to have something around 4 Kelvin. And that's why you have this system. This system, they have this cold head. On the cold head, you can buy. You can buy alone if you want, and then you have a small cryostat. Can go down to 4 Kelvin. Yeah, depend of from this cold head, you can have also 3 Kelvin. Yeah, if you have this one that you have, can go down to 3 Kelvin. Yeah, and then in principle the problem is solved. You have your 3 Kelvin. You can try then with the 3 Kelvin to cool down all the system. Yeah, and as soon the system is cold, and then you can begin. Let's say you have two systems: one to pre-cool to 3 Kelvin. On the other, you can cool down from 3 Kelvin to millikelvin. Yeah, and that's now these systems, the Triton systems. You don't need any liquid helium. You use the pulse tube to cool down to 3 Kelvin, and from there we can go from 3 Kelvin to 10 millikelvin or 8 millikelvin. I would like only to show first only the principle for a dilution fridge. Of course, this is a wet system, that means with liquid helium, but you see the difference is very small in between that for our system, you know. I don't know if you want to translate everything, this is good, but I think people understand, yeah.
На примере вот заливного криостата рассказывать, но разница очень маленькая. Практически все то же самое, вот у нас
Ну, то, что он показывает, это он говорит,
вот заливного,
да?
Yeah. And here I think I come from
Там
out.
с кем другой нет, на них всего 3-5 лет.
Нам нужно стандартный.
They say that they don't need to explain how liquid.
Ну, я понял, принцип он будет рассказывать. Я понял.
Because it's very similar. That's why if you understand that, you understand that. Yeah, because and all the graphic is almost the same. Yeah, yeah, I think these are outside here. The black one here is our OVC, the blue thing that you can see there. You know. And here, all this is small here, all this is small here around. This is the shields that we put in the other day. Yeah, important for us is the let's say the gray ones. These parts here. Yeah, and let's say we have our cryostat is exactly the same from here, from this point, from this primary impedance. You cannot read, but it's here. It's an impedance, and then this part here. Down, yeah, all this part down and this part up is exactly the same. The only difference that you have is that here, yeah, this is what is written here, condenser, yeah. The condenser we have as well, but you see this condenser is inside another volume here. You see here, this other volume here with this gray stuff, and this is liquid helium, yeah, that you don't have, yeah, and this liquid helium pre-cool the mixture that's coming here. So yeah, and in our case, this liquid is our pulse tube. Yeah, the pulse tube have a good contact with this part here, and then cool down the helium, the mixture that's coming. The mixture comes here inside, and then here's an impedance. We have also an impedance there, and then come down under here. These lines here are the heat exchanger. You have so a continuous heat exchanger there, and then you have a step heat exchanger. It's really a tube with some sinter material inside, yeah, and you flow the mixture through this heat exchanger, and first down, yeah, to the mixing chamber. This part here is the mixing chamber. I explained yesterday, you guys, and then you have these two phases from helium 3 and helium 4, yeah, and you pump out from the other side. You pump out this mixture, yeah, and you go again through the same heat